if you speak to theorists who really think about standard model and quantum field theory, they'll point out certain features of the theory that are quite striking. So, for example, like one of the things that seems really arbitrary in the standard model is that the matter particles, so the quarks and the leptons, come in what we call 3 generations. So the first generation is the stuff that the universe that we can see around us is made of. So it's like the electron and the up and the down quark are in the first generation, and that's what makes up the atoms in our body. Then there's a second generation which have copies of those first generation particles but heavier, and then another generation, the third generation, which is even heavier. And we don't know why these 3 generations exist. It's a real mystery. But in particle physics, there is this symmetry between particles and antiparticles, so like matter and antimatter. And in the Big Bang in cosmology, if you use the standard model, you get this prediction that basically you should have equal amounts of matter and antimatter produced, and then they would annihilate, and you end up with a universe with nothing in it. So the fact that we exist is a big mystery. And one of the things that has to happen in order for there to end up more matter in the universe than antimatter, you have to have a violation of the symmetry between matter and antimatter. And this symmetry can only be broken if there are at least 3 generations of matter. So it seems like the standard model, we still don't really know why those 3 generations are there, but we know that if there were not 3 generations, if there were fewer, there could not be matter-antimatter asymmetry, and therefore there wouldn't be anything in the universe. So it seems that these things that look random or strange, actually they're linked to why the universe is the way it is in quite a deep way.